This is our day 6 and today we are going to learn about half subtractor. So let's discuss theory about half subtractor. So this is the circuit diagram for half subtractor. In half subtractor we have two inputs A and B and we have two outputs, that is difference and borrow. So in this difference one input is subtracted from other. So here you can see B is subtracting from A. So that's why A minus B, and this is borrow. Okay, so let's see what are the expression for difference and borrow. For difference, expression is A XOR B. So that is A bar B plus A B bar. These things we already discussed, right? For borrow, expression is A bar and B. Okay, and this is the truth table for half subtractor. So as we have two inputs, so total 4 possibilities 0 0 0 1 1 0 and 1 1, and here difference and borrow is calculated from this expression, you can see. Okay, now let's write to the Verilog code for this half subtractor. So here I have written Verilog code for half subtractor. So module, then module name I wrote HS half subtractor, then inputs and outputs. A B are the inputs and difference and borrow are the outputs. So that's why input and output diff borrow. Okay, and after that here we are using data flow modeling, that's why I wrote assign, then we can directly write expression in this data flow modeling. So that's why I wrote diff equal to A XOR B, because for difference XOR we are passing inputs from XOR gates right here. So for difference both inputs passing from this XOR gate, and for borrow here one inputs passing from this NOT gate, then after that AND operation will perform. Okay, so that's why borrow expression is A bar and B. Okay, next, so here we wrote same thing, assign borrow equal to negation of A and B, then N module. So this is simple Verilog code for this half subtractor. Now let's move to the test bench for this half subtractor. So here I have written test bench. So module name is HSTB. This is just a name. Okay, and range for inputs and wire for outputs. So range A comma B and wire diff comma borrow. Then whatever the module we wrote, Verilog module for half subtractor, that we need to instantiate in this test bench. So that's why our module name is HS. So I wrote HS, then DUT, it's a instance name. Okay, and then A B inputs and diff borrow outputs. Okay, after that in this initial begin we need to pass our inputs. So initially we will keep A equal to 0 and B equal to 0, then after 10 seconds A equal to 0, B equal to 1, then after 10 seconds 1 0, then 1 1, then after 10 seconds finish. Okay, so these are the four possibilities we need to check. So we are getting expected simulated result or not, we need to check. Okay, now let's simulate this. Okay, so simulation is done. Here is the simulated result. So as we passes initially 0 0 in the from test bench, so that's why 0 0, then 0 1, then 1 0 and 1 1. Now let's verify these inputs and outputs from our truth table. See, for 0 0 case our difference and borrow is 0 0. So see here, for 0 0 its difference and borrow is 0 0. For 0 1 case, for 0 1 case 1 1, difference and borrow is 1 1. So here for 0 1 case difference and borrow is 1 1. Next for 1 0 case 1 0. For 1 0 case 1 0. Okay, and at last for 1 1 case it's 0 0. For 1 1 case it's 0 0. So whatever code we wrote, that is correct, because it gives exact result what we are expecting, right? So in this way we can write Verilog code for any module. We can write a test bench and we can simulate and observe expected result. Okay, so we will solve few more questions in the upcoming videos. Till that, thank you.